Okay, so yesterday we started 2.1. I gave you 3 book problems, 1, 5, and 6. You could have done problem 1 yesterday. And then a handout that I posted on Classroom. I do want to change something on the handout. You only have to do 1 through 6. So I'm going to take off the last 2 problems on there. So 3 book problems and then 1 through 6 only on the handout. These are a little more time consuming. It's not that it's hard, but it's tedious plugging a bunch of numbers in a calculator. We will learn a more efficient method, but we kind of have to start here and work our way up to that. So the next piece I want to talk about is velocity. If we take a look, I have an example here. So suppose that a ball is dropped from the upper observation deck of the CN Tower in Toronto, 450 meters above the ground. Find the velocity after 5 seconds. Okay, so we are going to use this vertical motion equation. We've seen it before in some of our college algebra and things. We had this equation pop up. You might have seen it in physics class. So this is, S of t is just representing the height at a given point. My v sub 0 is beginning velocity. Now, if you start out dropping the ball, so you're holding it and you just drop it, does it have any beginning velocity? No. Okay, so our v sub 0 is just 0. We're going to drop that off. Our h sub 0 is beginning height. So we could use the 450 for that. There's really 2 ways we can think about this problem. The beginning height is 450, or we could think of it as that being height of 0 and then it going down from there. We're really just worried about the velocity. So to make my equation as simple as possible, we're just going to use this, the negative 4.9 t squared. That's all we really need to get our velocity piece. And we'll just treat the observation deck as a beginning height of 0 for this scenario. Now, when I'm asking you to find velocity, average velocity is really just a slope. We know slope is the change in y over the change in x. So it would be the change in height over the s of t over the change in time. So all I'm really asking you to do here is kind of like yesterday, making that table and seeing what my velocities approach. Because I don't have enough information to say at one particular point my velocity is this. We need 2 ordered pairs to find a slope. So we're going to have to make that table like we were doing yesterday. So I think I put a blank slide next to this that you can use for working that out. What point am I comparing all of these to? You will need a calculator, by the way. All of these I'm going to be finding the slope compared to when my time was 5 and I need my height at that point. So plug a 5 into our height equation. So we are going to do an x, which really is like t here, whichever you want to think about. Our y, which in this case is s of t. Maybe I should label them like that, not confuse you. T and s of t. It's just your x and your y. and then we're going to do the slope. All right, we need times getting close to 5. So I asked you to do 3 above and 3 below in your homework. So things smaller than 5 but getting close to it, what would that be? .9, 4.99, 4.999. From the other way, things bigger, maybe 5.1, 5.01, 5.001. Okay, did you understand yesterday what you were doing with these numbers? So you're first going to plug them in to our equation, the negative 4.9t squared. That will give you your y. And then you have to find the slope between these 2 points. Okay, so let's do a couple together. If I put in 4.9, negative 4.9 times 4.9 squared, get negative 117.649. Now I do my slope. My y2, negative 122.5, minus y1, negative 117.649, over x2, so 5, minus 4.9. Everybody get that? Understand how I got that? 4.99. I haven't shown you guys your test yet, have I? Okay. Don't let me forget to hand those back. The 4.99, so we plug that in. Can we divvy this up and you guys work some of these now? Do you know how to do them? How about Blake and Cody? You guys do 4.99 and then compare your answers with each other to make sure you got them right. Kelson and Peyton, once you do 4.999. Riley and Blaine do 5.1. Lauren will do 5.01. So you plug them into your height equations. And then calculate your slope. So we've got our y's, and then tell me what you got for your slopes. When you put in 4.99, what'd you get for your slope?
Negative 48.95.
Okay, when you did 4.99, what'd we get? Okay, 5.1, what'd you get?
Negative 49.49.
5.01. Did you plug it in? Okay. Get negative 49.049. 5.001 would get negative 49.0049. So, can we tell what these are approaching? What does it look like both of them are getting close to? Negative 49. So we would estimate our velocity at 5 seconds to be negative 49 meters per second. Why would we have a negative velocity? It's going down. Velocity is just like speed with direction. Okay, so this idea, like what we were doing yesterday with the tables, that is actually calculating a a velocity, more specifically the average velocity. We can also talk about instantaneous velocity. So instantaneous velocity is this right here. Every one of these numbers in our table were an average velocity because they were found by the slope. The instantaneous is when I try to say at 5 seconds exactly, what is the velocity? That's the instantaneous. So the average velocity is a slope, the change in between two different points in time. Instantaneous is just at one particular point in time, the velocity. So we'll jot that down. So we use all of those velocities in the table to estimate the velocity at one given point. Just like yesterday, we were using the slopes of the secant lines to estimate the slope of a tangent line. So the secant and tangent line are actually related to your velocity. Slope of the secant line, that is the average velocity. It's between two given points. Slope of a tangent line, the thing we're trying to estimate, is the instantaneous velocity. Any questions? I'd like to do one last example. So a rock is thrown upward with a velocity of 20 meters per second. The height in meters t seconds later is given by this equation, y equals 20t minus 16t squared. Part A, find the average velocity during each time period. I'm pretty sure some of your homework questions are like this, maybe question 5 if I remember out of the book. It gives you a time period. It wants the average velocity. That's just asking you to find the slope. When it gives you this interval, those are two different x values. So how am I going to get my y's? Plug them into your equation. So if I put in a 1, I get 20 minus 16, which is a 4. If I put in a 1.5, we get negative 6. And then when I say find the average velocity between them, what am I asking you to do? So y2 minus y1 over x2 minus x1. So I get negative 10 over 0.5, so that's negative 20. Velocity is meters per second. Okay, so that's the first one. Second one. I'm still using the 1. My second point, my x is 1.1. So you plug that into your y equation. You should get a 2.64. And we'll do slope. y2 minus y1 over x2 minus x1. why don't you guys take a minute, see if you can do the last two, and then see if you can answer part B. Did you guys get 3 and 4? On the third one, I got negative 12.16. The fourth, negative 12.016. So then, those are all the average velocities, the slopes. Part B says estimate the instantaneous velocity at 1. So all of these, if you notice, were compared to the point when my time was 1. So the instantaneous velocity at 1 is like saying, what are these numbers approaching? And what does that look like? Negative 12 meters per second. So that is the end of this section. Yesterday, I gave book problems and I gave a handout. I said at the beginning on the handout, I'm going to take off the last 2 questions. I just want you to do 1 through 6 on that handout, so you don't have to do the last 2. We're going to have the rest of class to work on this. Tomorrow, there will be a video posted. I'm starting section 2. So I posted last year's video, and then I gave you homework is just going to be a handout. So the homework should be really short tomorrow. That handout shouldn't take you more than 10 minutes. If you're spending longer than that on it, shoot me an email because you're missing something and making it harder than it needs to be. I also gave you back your tests, so take a look at those, and I'll probably just come around and answer individual questions. Do you guys have any questions for me over this section or the plan for tomorrow right now?